And welcome, pre-calculus, welcome. Oh my goodness, I am gone because my wife's going to the eye doctor and something about her getting her eyes dilated again and not being able to drive home from Fairview Heights, yada, 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 whatever. So anyway, here's the video. I apologize in advance. It is 2:02 on Wednesday afternoon. That's right, this is 7th hour Wednesday. And I am making the video now because I want to make sure that I don't go over time because I know what we have to cover today. OMG, it's a lot. But first, Super Sub, could you please hand out the practice memory quiz? The practice memory quiz. Go ahead and hand that baby out. And we'll go through the answers. This is exactly the memory quiz, right? So it's nothing like, oh, that's going to be a trickaroo. You're going to change things tomorrow. No, I'm not. I'm writing down the questions as you're getting them, right? I'm writing down the questions as you're getting them. And I do need to keep that clock up there because wow, because otherwise I may run out of time. Okay, here we go. So hopefully you now have that paper because Super Sub is a professional hander outer. And here we go, filling in some blanks. You ready? Tangent's 1 over cotangent. You don't have to put the theta. Cotangent is 1 over tangent. You don't have to put the theta. Sine, oh, what are we going to do for sine? Sine is 1 over cosecant. Don't have to put the theta. Cosecant is 1 over sine. Wow, that's repetitive. Cosine is 1 over secant. And secant is 1 over cosine. It's really that simple. And now we have just started 7th hour grade. Tangent, again, even though you're looking at questions 1 and 2, and you're like, what else could I put for tangent and cotangent? Tangent is sine over cosine. And cotangent is cosine over sine. Okay, so I didn't follow the exact order of the poster. Oh well, get over it. Here's questions 9. State the 3 Pythagorean identities. So 9, 10, and 11, you got to be able to do them all by yourself. So you got to know that the first one is sine squared plus cosine squared is 1. You don't need to put the thetas. Then you know what comes after sine and cosine. Oh yeah, tangent. So then it'd be tangent squared plus 1 equals secant squared. Gonna have to memorize that. And then the last one is the c's. So this is tangent squared, this is cotangent squared. Oh, hello. Cotangent squared plus 1. And then instead of secant, it's cosecant squared. Okay, so that was pretty easy. And then questions 12 and 11 are 12 and 13. Trying to rush, which 2 functions are even? Oh, we know that to be cosine and secant. Is that the first time that you've written the word secant forever? Cosine and secant, if you want to write, and more power to you. Okay, that was the practice quiz. Tomorrow it's going to be identical. It's just not going to have the other stuff written on the top of it, but everything else is going to look, so it's just not going to say practice and it's not going to say real quiz tomorrow because that wouldn't make sense since you're taking the real quiz. Yeah, you know what I mean. Okay, now, Super Sub, could you please hand out today's notes, which are 6.2 notes, 6.2 notes, and we have, like, I'm really sorry that I'm not here today, but in a way, I'm kind of, I mean, I'm okay with it because I'm making this video because you guys could go back and watch this. This could be really, 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 really scary for you, okay? Simplifying trig expressions. So I hope it's not, but I'm going to go through some ways to do the problem that hopefully will give you a better idea, like a strategy. Okay, I had to recopy these because I wanted you guys to have the answers. So the answer for this one is cosine theta. Okay, I'm going to be referencing the poster during this. Got it? I'm going to be referencing the poster during this. So I'm going to be looking up there, trying to figure out the property and saying it out loud as I go. Whenever you're doing trig proofs, because that's what this is, you already have the answer. The answer is cosine theta. We're trying to make this whole left side just turn into cosine theta. Okay, so you don't rewrite the cosine theta. In fact, the last thing you're going to get down here is cosine theta. Okay, so you already know the answer. You just got to prove it. And anytime that you are in a bind and you're like not sure what to do, my clue is to switch to sine and cosine. Well, using property number 3, I know that this is 1 over cosine, and I'm not going to write the thetas. And then this is just going to stay sine, but since this is a fraction, I'm going to write this as a fraction. And then tangent, I'm going to use property 7, and so that's sine over cosine. Okay, so property 3 and property 7. Property 3 and property 7. Don't write that part, okay? And so now, I have everything in sine and cosine terms. Yippee skippy, I think I can do this problem. So now I'm going to simplify. And when I simplify, I can't do anything with this fraction because it's cool. It's sine and cosine. But then this guy's going to be sine squared over cosine. Hey, would you looky there? I have a common denominator. So I can write it as 1 fraction. What a coincidence. Okay. Did you know, this is a side note, so I'm going to write it in red. Did you know that sine squared plus cosine squared is 1? Which means that cosine squared is 1 minus sine squared. Okay, so you don't have to write that part. That's just a side step. Now you should notice that this is the same as that, and I'm going to replace it. So that means when I replace it, I'm going to replace it with cosine squared. So yellow becomes cosine squared. So it's going to be cosine squared over cosine, which equals cosine theta, write the theta at the very end, and then put 3 dots. And those 3 dots I can explain later, but it's just the end of a proof, and it just means I did it, I proved it, okay? It just means I'm done, I proved it. Another way to finish a proof would be to write the letters QED, Q period, E period, D period, which is some Latin stuff, I think. Latin, probably, or Greek. I'm going to go with Latin. But anyway, I would finish them with the 3 little, anytime you're finished with the proof, you should be doing that, okay? In geometry, it was different. You knew what you were trying to prove, but your last step was usually like CPCTC or, you know, alternate interior angles congruent, whatever. Not anymore. You have the answer, we proved it. Okay, so my big hint is if you ever get stuck and you don't see a plan, switch everything to sine and cosine. Got it? That's what I did with green. Let's go to question number 2, because you are now probably seeing stars after I just did that problem, right? That was a little weird. You're going to get used to this. All these are just fun little math puzzles. That's all this is. Can you apply the properties that you were supposed to memorize? And then we're going to turn this baby into what? 2 sine A? 2 sine A. Okay, let's see if we can do it. I'm loving how I'm running out of room there. All right, do you think I'm going to change that one? Nah. Do you think I'm going to change that one? Nah. Do you think I'm going to change that one? Yeah, it's not sine or cosine. So I'm going to look over at the board and I'm going to say that tangent using property 7 is sine over cosine. That looks silly. It's sine over cosine. Okay, now since that's a fraction, I'm going to make you a fraction, and I'm going to make you a fraction, because why not? I can't change the first guy, but I sure as heck can cancel out this with that, and I get sine. Turns out I really didn't need that to be a fraction. Sine plus sine is 2 sine A. 3 dots, boom. 3 dots, boom. Put the letter at the very end, okay, while you're doing the actual proof. So long as we're just doing one letter, later on we're going to have more than one letter. That's when it gets really fun, like sine A and cosine B. Oh, those are fun. It's all coming up, but this is just a start. Did I do anything different? Was my approach any different between these two problems? Nope. I just switched to sine and cosine, and I tell you that I did prove it. Yay, 3 dots. Draw the 3 dots. When else do you get to? Number 3. Man, we're cruising. We'd only have 1,000 more problems to do. Okay, cotangent squared minus cosecant squared, cotangent squared minus cosecant squared, and we're going to turn that into -1. Doesn't seem possible, but let's find out. Okay, if cotangent is cosine over sine, property 8. So maybe, can we do this one different? Everybody, do you see, look at property number 13. Okay, property 13 says cotangent squared plus 1 is cosecant squared. Oh, okay. So I'm going to take, and I'm going to make this, see how that, and this are the same thing. I think that would be cool. Let's find out together. I would take, it'd be cotangent squared minus parenthesis cotangent squared plus 1. Oh, okay, so I just replaced yellow with cotangent squared plus 1. And then it'd be, I got to distribute, and so it'd be cotangent squared minus cotangent squared, yippee, minus 1. And that equals -1, 3 dots. Now, that was just to kind of save time. Tomorrow, I could redo number 3 in terms of sine and cosine, because it really does work, okay? I really could do sine and cosine again. This one, I just was like, dang, I know we have a property that uses those words. I looked over at the chart and said, yepper, look at number 13. And there it is, okay? Next, number 4. Hang with me. We only have, oh my gosh, we have to go to number 12. Okay, I can do this, and then I got to get to track practice. And I have to do outside bus duty. That's cool. All right, this problem looked like this. Yikes. Okay. What are we trying to get to? Secant squared? Okay, let's do it. I guess I could distribute, but that would not be cool. Or maybe instead of doing sine and cosine again, maybe since this is tangent and cotangent, and they are kind of related to secant, maybe I could do something with this. What in the snap is sine over cosine? Oh, look at property number 7. It's tangent. And just like that, the fraction went away. Yay, that became tangent because tangent sine over cosine. Now distribute. Tangent squared plus tangent cotangent. Okay, look at property number 4. Oh, number 4. What is tangent times cotangent? Oh, it's 1. And then look at property 12, and that equals secant squared. I don't even know what letters we're using on number 4. X, thank goodness. And 3 dots, boom. That one also could have been done differently. I could have made tangent sine over cosine, and I could have made cotangent cosine over sine and got a common denominator and added them together. But wowzer, that would have been a headache. I can do it tomorrow if necessary. For some of you guys, if you want to go back through and try number 4, switching everything to sine and cosine first, go for it. Ditto for this problem. I could have made this cosine squared over sine squared, and I could have made this 1 over sine squared. Okay, so this is a whole new world. Sing it. I'm not going to sing it on the recording because, you know, then you guys would have me singing a whole new world, and I'm not going to right now anyway. I can do it live, but not, you know, no, not on recording. Number 5, I'll sing that part. Cosecant minus some weird fraction. Cotangent squared over cosecant. What in the Jack Russell Terrier am I going to do with this? Man, it would be cool if I could get one fraction. Okay, so I'm going to write this over 1. And then I got to turn this into sine. Okay, so that's my goal, just to get it to sine. Let's see if I can do that. All right, the rules of algebra still apply. If I want to get a common denominator of cosecant, I need to multiply this puppy by cosecant over cosecant. Okay, so that's going to be cosecant squared over cosecant minus cotangent squared. Ooh, look at that too, fancy. Over cosecant. But then I can write it all as one fraction. And then I can write this as cosecant squared minus cotangent squared. I'm still not even in the world of sine and cosine yet. So why did I stick with these words? Because doggone, it would have been a lot of headache to turn that to 1 over sine, change that to cosine squared over sine squared, and change that to 1 over sine. But I could have. And again, if that's how you want to do it, or we can try it, we can do that tomorrow. Okay, everybody, look at property number 13. Look at property 13. 13 says cotangent squared, this is a side step, cotangent squared plus 1 is cosecant squared. So now I'm going to move that cotangent squared over. And would you look at that? This matches that. So I'm going to replace yellow with a 1. This was a side step. Side step. I'm going to replace yellow with a 1. 1 over cosecant. But I look at property number, oh, that one's not on there. But if I look at property number 2, I know that 1 over cosecant is going to be sine. What letter are we using? Theta. And I know that you cannot contain your enthusiasm for trig proofs. They're called trig identities or trig proofs. The thing is, I'll give you the answer. You just got to get there. Okay? How do you get there? You use the 13 properties that are on the poster. You use those properties like crazy. One of them has to work. You use some algebra rules, like get a common denominator. Okay? Later on, we're going to factor. Let's keep going. Number 6, I know the video's already 20 minutes long and we're not even done with the stinking front of the notes. Come on, come on, we can do it. Plus I gotta be done. Number 6, all right, cosecant minus sine over cosecant, that's weird. And we're gonna turn that into cosine squared. All right, okay, can we do it? Are you allowed to cancel out the cosecants? No, because of that minus sign. I guess, I mean, I don't know. We're so close to everything being in sine. Let's go ahead and do that. Okay, so here we go. Cosecant's 1 over sine. Sine, we're just going to write it as a fraction. And then all over 1 over sine. Okay, let's see if I did everything right there. Heck yeah, I did. Now I'm going to get a common denominator. So I got to just worry about the top. I'm going to multiply u like that. And it's going to be 1 minus sine squared all over sine. And then the bottom hasn't changed. Oh, where's my pen? Let's play the game. The bottom hasn't changed. The bottom hasn't changed. Okay, remember, if you are dividing by a fraction, it's the same as multiplying by its reciprocal. So then that is going to be 1 minus sine squared over sine times sine over 1. And then I'm going to go like this. And I'm going to go like this. And I'm going to get 1 minus sine squared. But now I look at property number 11. Property number 11 says sine squared plus cosine squared is 1. So if I move the sine squared to the right side, I would have cosine squared equaling 1 minus sine squared. So this puppy, what letter is number 6? Beta. 3 dot boom. Man, okay. Some people really like these. Like some people like doing jigsaw puzzles. Some people like doing Sudoku puzzles. Some people like doing word searches or number fill-ins. Some people like doing trig identities because it's a good exercise just to keep your brain fresh, okay? I'm just using algebra rules with fancy words, all right? So there's some new rules on the poster, 1 through 13. Those are some new rules. And then I'm just using algebra. Let's keep going. Surely the problems can't get any harder. Ha ha! Oh, goodness. I'm going to run out of time. I'm going to not run out of time. Secant over sine. I think part of the problem was I did not write these problems down first. And that is creating an issue for me because my handwriting's not looking the best right now either, is it? All right. Yeah, let's do it. Let's get a common denominator. Before I switch anything, let's just multiply this guy by cosine over cosine. And let's just multiply this guy by sine over sine. Let's see what happens. Okay, so the bottom is going to be sine times cosine. Yippee. The top is going to be a cosine times a secant minus a sine squared. My ends are looking, man, that's looking sweet. Minus sine squared. Okay. Hey, anybody want to guess what cosine times secant is? Anybody at all? It's property number 6, which is 1. So this is going to be 1 minus sine squared all over sine cosine. Okay, I'm feeling pretty good about that. Now look at property 11. If I move the sine squared over, just like we did on the previous problem, I get cosine squared. So yellow, this baby, is just like, it's just like this one. Sorry. And then that means that the top is going to be cosine squared, and the bottom is going to be sine cosine. And then you get out your marker and you go whoosh and whoosh, just like that. And so I'm left with cosine over sine, but then I look at my poster one more time and I say cosine over sine is, looky there, property number 8, cotangent, and number 7, we're using the letter U, why not? 3 dots. Boom. Wowza. This is definitely overload, right? This is going to take a while to do, but man, we just got to push forward right now. We're just going to push forward. Hopefully, hopefully it's clicking today, but if it's not clicking today, the more that we do of these, I promise it'll click at some point. Some people might be getting it right now, but others, it's going to be middle of next week, okay? And so that's something that you really haven't ran into. But now we've entered a whole new world. Someone sing it out. Cruz, just like you've done before, you know, when you hit the high notes, if you could sing that out right now, that would be awesome. Go ahead. No? Yeah. All right. This is number 8. Does anybody think that Cruz could hit the high note? Cool. I hope I wrote number 8 down correctly. I did. These words are all over the place. Tangent and secant and cosine. Cosine's cool, but I don't know what else to do. I almost, when I did the answer key, I almost started doing the conjugate, multiplying top and bottom by secant plus cosine. But man, that started creating a big old mess. So if you could see my notes, I scribbled that out. And then I thought to myself, no, no, no. Let's just go by the old standby, which is changing everything to sine and cosine. Okay, property number 7. Tangent is sine over cosine. Secant is 1 over cosine. And since that's a fraction, let's just make that a fraction too. Okay, common denominator on the bottom. I have to multiply this puppy by cosine over cosine, right? So then it's going to be sine over cosine, but then whoosh, 1 minus cosine squared over cosine. Oh, okay, I'm feeling pretty good. Remember, dividing by a fraction is the same as multiplying by its what? Reciprocal. That's right. So it's going to be sine cosine times cosine over 1 minus cosine squared. And then I get out this marker and I go whoosh, and I go whoosh, like that. Okay, man, we're close, right? So this is sine. Hey, wouldn't that be cool if that wasn't 1 minus cosine squared, but it was something else? Yeah, it would be. And if you look at property number 11, if I were to move the cosine over to the right, this would become sine squared. I use property 11. And then I can go like this, whoosh, and I can go like this, whoosh, and I'm left with 1 over sine. I wish I could stop there, but I look at the answer, but everybody knows that 1 over sine is the same as cosecant. Look at number 8. We were using it, fish and alpha, 3 dot, boom. Wow. I know I'm going fast. I've already talked for 30 minutes. I'm getting parched. I don't have anything to drink. It's 2:31. I'm running out of time. Let's keep on going. Remember, I will post this video. Thursday evening also, okay? Number 9. Man, that's going to be a big, I'll just put it on my YouTube channel. You know, 24K classroom. There you go. Number 9. Okay, cosecant plus 1, cosecant plus 1, and cosecant minus 1. That's almost a little redundant. All over cosecant squared. All right, that's way too much. And we're going to try to turn this baby into cosine squared. Okay, let's do it. Here we go. I'm going to FOIL the top. That's right, I said the F word on video. FOIL. I'm going to FOIL the top. And when I FOIL the top correctly, I get cosecant squared minus cosecant plus cosecant minus 1 all over cosecant squared. Okay, hey, looky there. These babies go away. Shocker, right? So then it's going to be cosecant squared minus 1 over cosecant squared. I don't know what to do on this one. Okay, let's try it. We can do this. Okay, let's do it. I am looking at, oh gosh. I was looking at property 13 for the top and changing it to cotangent squared, but that would create more of a headache. I wish those cosecants could cancel out. Ah, they can. Because of this minus sign, I can write it as 2 fractions. Cosecant squared over cosecant squared minus 1 over cosecant squared. Ooh, fancy. So this is 1 minus, if 1 over cosecant is sine, 1 over cosecant squared is sine squared. That is property number, it's not up there, but it's kind of like property number 2, okay, but squared. You're allowed to square it. It still works. All right, BTW, what is 1 minus sine squared? 1 minus sine squared is cosine squared. Let's throw in the official letter for number 9, which was an X. And let's throw on those 3 dots. Boom. And we're done with that one. Wow. I mean, we are in deep. Why not let's just keep on digging, because I need to get through these notes, and it would be awesome if we did now so that I don't have to teach it again. Here goes, and you can watch this video over and over. It'll be posted, don't you worry. Number 10. All right, this one is tangent plus cosine over 1 plus sine. Oh, shucks. What in the snap am I going to do? Okay. If I write this as sine over cosine, that gets me nowhere. Well, I don't know. Gosh. I really don't want to. Okay. Let's try something. We're going to write this as sine over cosine. Oh, wait. What are we trying to prove? Number 10, we're trying to get it to be secant. Okay. All right, cool. So if I can get it to 1 over cosine, I'm good. Here we go. I'm going to change that. I like that a lot. I'm going to, what am I going to do now? Okay, could I get a common denominator? Sine plus sine squared and cosine squared. Huh. How about we do this? I like the way that I was just talking about, but I like this way maybe mucho bettero. And I'll show you what my thinking was. All right, this is sine over cosine. That hasn't changed. The top, so I multiply by the conjugate. Just a clever form of 1. All right, so the top is going to be cosine minus cosine sine all over 1 minus sine squared. So this hasn't changed. The top hasn't changed. But the bottom turns into cosine squared. Okay, I'm cool with that. Now I can go over here and multiply this puppy by cos over cos and write it as one fraction. So it's going to be cosine sine plus cosine minus cosine sine all over cosine squared. Man, I hope this works. Here we go. This guy subtracts that guy, and they go poof, and I'm left with cosine over cosine squared, which is 1 over cosine. Guess what that is? Guess what that is? Anybody? Number 10, that is secant theta. And just like that, we celebrate with 3 dots, boom. 3 dots, boom. Just like that, 3 dots, boom. Wow, 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 wow. Somebody tonight, you guys could go back up here and just multiply this fraction by cosine over cosine and multiply this guy by 1 plus sine and 1 plus sine and see what happens. That would be a fun experiment, wouldn't it? It's just a fun little puzzle. It's just a fun little trig puzzle. There we go. I like that a lot. Sorry, I'll scroll back. There you go. Number, I don't know. Number 11. Gosh, can we do this? This video, oh, come on. Number 11, I don't care that I'm doing it in blue. Tangent squared minus tangent squared sine squared. And we're going to try to turn that into sine squared. Oh, okay. I think we can do that. All right, factor out a tangent squared. It'd be 1 minus sine squared. Okay, this is going to become sine squared over cosine squared. Love that. This is going to become cosine squared over 1. Yes! And sine squared y. 3 dots. 1, 2, 3. Done. Boom. Ooh, I like that. Hey, what'd you do, Mr. Blanchard? All I did was factor out a tangent squared because I noticed that they were in common. So I just took it out right there. It's the reverse of distributing. I factored it out. Last one. Come on. Let's do it. We can do this. Thank goodness. And then everybody can take a big sigh of relief after number 12 because there isn't homework today. It'll be tomorrow. Wow. All right, don't even think about tomorrow. Here we go. Sine cubed. Cubed? Yeah, sine cubed. Cosecant squared minus sine cubed. Oh, well, guess what I'm going to do? Too easy, too predictable. All over cosine cubed. Too easy. And this is going to be tangent. Do you guys want to try this one? No, I'm not going to give you time to try this one. Everybody should notice that that's sine cubed that's going to come out today. And it's going to be cosecant squared minus uno all over cosine cubed. But Sine cubed over cosine cubed is tangent cubed. You better believe it is. And then cosecant squared minus 1, if I look at property number 13, that is cotangent. I almost wrote cotangent cubed, but it's not. It's cotangent squared. Well, this is tangent times tangent squared times cotangent squared. But everybody knows that tangent times cotangent is 1. So that's just going to be tangent times 1, which is tangent, duh. And number 12 is finished with 3 dots. Oh my goodness, we did it. I apologize. 41 minutes long. And I say to you, hang on, good day.